Hey friends, it's Scott. I want to thank our new sponsor, MailTrap, modern email delivery for developers. They integrate straight into your code with their SDKs. You get unified transactional and promotional email delivery, 24/7 support. You contact humans, not AI chatbots. We'll give you 3,500 emails monthly in the free tier, and you can try them out at mailtrap.io today. That's mailtrap.io today. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes, and today I have the distinct pleasure of chatting with Eric Lippert, designer of fine programming languages, very likely ones that you have worked on. He worked at Microsoft, he worked at Meta, he's the author of several programming books, and the voice behind the influential blog Fabulous Adventures in Coding, which has guided myself and countless other developers through the intricacies of language design and compiler construction. You're just a gift. And you're the gift that keeps on giving. And what you're giving us today now is a new book that is currently being written called Fabulous Adventures in Data, Structures, and Algorithms. And it is now 7 of 19 chapters available. It's a live book. You're writing this right now. You're probably writing it today. I'm on Manning. I've got early access. Folks that are listening can click a link in the show notes and get access as well. Watching you write the book is cool. Chapter 7 just came out today.
Yeah, I'm super excited.
That's so cool. Why this book now? We're at the peak of AI-assisted coding. I thought we don't need to know any of this stuff anymore.
Well, first of all, Scott, it's a pleasure to talk to you, and thank you for that very kind introduction. So why this book now? Why any book now is the question that I had for my editor. The way this came about was I was editing a book on better blog writing, better short form writing for developers, which is a topic that I am very passionate about, and that I believe you wrote the afterword to that book.
I did.
Yeah. And after we got that book put to bed and it was ready to go to print, the editor asked me, "Oh, are there any books on Microsoft development that you think we ought to write?" And I was like, "Well, I have been out of the Microsoft ecosystem for several years now, so I'm not really sure what's the current hotness there. But if I was to write another book, what I would write? I would write a book that was like all of the weird stuff that you don't learn in school that I encountered during my career of building developer tools, that involved reading a lot of papers and digesting them and then turning them into actual working production code." And the editor, Jonathan, said to me that the title maybe needs work, but could you write me a proposal for this book? And so I wrote a proposal for the book, and he showed it to a bunch of people who I thought were my friends, and they all told him that he should convince me to actually write the book, and he convinced me to actually write the book. So why a book now? Why not just a blog or a website? I still really strongly believe in the learning style of reading words on paper or reading words in a long form, in like long form electronic form. I think that's a really powerful way to learn. There's a lot of ways to learn. I learn a lot from videos. I learn a lot from podcasts. But when I really want to grasp a topic, I get the papers on it and I just go through and I print them out on actual paper and I mark them up like a caveman. And so then why this book at this time now when we've got AI coding and vibe coding? And the answer to that is don't outsource the problem solving. The problem solving is it. The problem solving is the thing. If you are outsourcing the problem solving part, the turning it into syntax, that's fine, right? Outsource that all you want. Use all the tools you want for that. But the having a clarity of thought and being able to relate a problem that you have in a real world industrial setting, a real world business case setting, and then turn that have a thought about how you should solve that problem, and then turn that thought into real working code that makes a machine do what you want. That's the whole game for me. And building tools to help people do that better, to help translate their thoughts into reality. That's what coding is all about, and that's what this book is all about. And it's about having fun along the way.
And it doesn't, I would say it doesn't shy away from, I wouldn't say difficulty, but like, I don't know, not even esoterica. Like, I just want to give people a sense of this book, because honestly, like, I know that's named after your blogs. It's Fabulous Adventures in Coding is your blog. Yep. Fabulous Adventures in Data Structures and Algorithm is the book. And you start with starting a fabulous adventure. But then, like, part 1, section 4, memoizing immutable quad trees to make a better life. Like, you didn't start with Hello World.
I did not start with Hello World. No, the book is organized into 3 major sections, and as you pointed out, the first of those sections is available on the internet. And the way that works is essentially you pay for the book now, you get early access to it. Mm-hmm. As I write more chapters, they show up on the website, and then you get a copy of the book at the end.
Yeah, it's pretty cool.
Yeah, so the first third of the book is looking at traditional topics, lists and queues and stacks and combinatoric algorithms and trees and quad trees and things like that, but all with kind of a weird twist on them. Not the kind of stuff that you would see in a typical data structures and algorithms course in an undergraduate curriculum, for example. Stuff that I encountered during my career that I thought was unusual, and stuff that made me change the way I think about programming. Then the second third of the book is going to be some more esoteric algorithms that I encountered when I was developing developer tools over my career. Things like unification and anti-unification. And then the last third of the book is going to be algorithms and data structures that I learned about when I was doing stochastic programming at Facebook. So dealing with random quantities, how are random quantities related to other data types that you are very familiar with, like sequences or tasks or nullables, right? There's an underlying structure to all of those data types, and I'm going to have little explorations along the way of what that structure is.
Yeah, I think I want to understand. This is a tough one. We're in a weird time right now where we spent the last 10 years, 15 years, really encouraging everyone to learn how to code. Mm-hmm. And there's a lot of different kinds of programmers out there. There's a lot of different kinds of, but we all just say programmer, coder, engineer. Mm-hmm. And it's not a formal thing. Like there's no, it's not like you go to the medical board and you get like board certified. You're not a board certified programmer, but like someone might get a master's from Carnegie Mellon, and then someone might have a software engineering degree from Portland Community College, just like me. Mm-hmm. And we're all kind of like peers. But someone might be listening and you just said, yeah, when I was doing stochastic programming, and they might be doing text boxes over data with React.
Sure.
Those are different kinds of programmers. What kind of programmer is this book for? Is it for anyone who wants to fill in the gaps? They might just be doing text boxes over data, or they might be doing really, really deep, interesting systems work on the back end of something. But we're all just kind of coders in the end.
Well, that's a really good point, that we are all really just coders. Like that's what we do. We sit down in front of this box and we issue commands, and then those commands turn into a real working thing, and that's a bit magical. And it's nice that there is not a governing body that is gatekeeping that. Coding should be accessible to everybody. I started programming on the Commodore PET in my elementary school library. Nobody stopped me from doing that. People encouraged me to do that, and that's why I'm here today. And I know you have a similar story. So what kind of coder is this book for? This book is for curious coders. This book is for people who are coders, right? It's not a tutorial, as you point out. It starts fairly hard, but it is for people who have maybe wondered what is the mathematics that underlies the systems that we see. Like why do so many languages have tuples? Why do so many languages have sequences? Is there a relationship between a device that produces a bunch of numbers and a device that consumes a bunch of numbers? Is there what are the underlying structural similarities? Um, and also, just what's the weird, cool stuff? I just wrote a chapter on, how you're using your IDE and you hit the format button and it automatically formats your code to be pretty.
Mm-hmm.
How does that work? There was a day when I didn't know how that worked. It was just magic. And then I had to actually write a code formatter, and I did a little bit of research into how code formatters work, and it's really cool. There's a lot of very simple logic that can be combined together in complex ways to capture the notion of what is prettiness for code formatting. And if you get the API right, then it becomes very natural to write a little program that says, okay, we'll try it this way and see if that's pretty. Oh no, try it that way and see if that's pretty. And it's a really really neat algorithm. I had a lot of fun when I learned about it, and I figured other people would too. So yeah, that's really what it's for. It's for the curious.
Now, I love that, by the way. Like, like if there was a lot of time in the last couple of years on social where everyone was like, talking about hustle culture and like, if you're not programming after 5 p.m. or whatever, it's not about that level of interest in the craft. It's just about curiosity. It's about like, how does that work? Like I was at McDonald's recently and they've got they got those giant iPads. And, I'm like, I wonder who wrote that. I wonder how that works. What's the back end look like, And then I'm adjusting the heat on my, my thermostat. And I'm like, I wonder who wrote that. I wonder how that works. What's the back end for that? Is this running like an embedded system? Is this running Linux? Like, is this Raspberry Pi? And then the next thing you know, you've ripped your thermostat off the wall and you're like trying to figure out what's going on.
Yeah.
That level of curiosity, I don't know how to not have that.
Mm-hmm.
I don't know how to not think to myself, like, why is that airport running a text UI and not a GUI? Like, who can I talk to? And the next thing you know, they're on my podcast, that kind of stuff.
I often think about an interview that I ran at Microsoft many, many, many years ago, where I posed a technical problem, and the problem involved generating a unique integer. And the developer that I was interviewing was a database developer, and he said, "Oh, well, I would just create a table, and then I would mark one of the columns as having a unique identifier." And I said, "Okay, suppose I'm hiring you for the database team, and the database doesn't have that feature yet. What would you do?" And he got the strangest look on his face, and he said, "I never thought about the fact that somebody had to write that code. It didn't just come into existence on its own." I was like, "Yeah, and you can be that guy."
Mm. Yeah, that kind of stuff is so fun and so interesting. So I want to go back to this stochastic programming idea. This is interesting to me because in a time of AI,
Mm-hmm.
where AI is really just a branding term on top of like 50 years of machine learning and statistics and math. And I think people don't realize that because they feel like AI just happened last year or whatever. Like
Yeah.
ChatGPT just popped into existence a couple of years ago. But typically it's data in and reliably deterministic data out, and it's always been that way. And now we're in this place where we have uncertainty.
Mm-hmm.
And it's like a deterministic program would say, if I need 100 units of this widget, order 100 units. But a stochastic program might be like, we could need 80, we might need 120. Like, I don't know. What's the way to minimize my expected cost on the number of units? It's optimizing on averages and stuff like that because it's squishy.
Yes, that's a great point. So let me talk a little bit about what I mean by stochastic programming. But first, let me address your point about branding. There's a joke. I don't know who said it first, but the joke is that we tell the public that it's artificial intelligence. We tell the developers, or we tell the investors that it's machine learning. We tell the developers that it's stochastic programming, and it's actually linear interpolation.
That's a That's a pretty specific joke for a pretty specific audience. I can hear one of our listeners has just chuckled.
But that's the joke is not too far from the truth.
No, it really isn't.
There's nothing intelligent about artificial intelligence. Well, actually, that's not true. There is plenty that's intelligent about
it's behind it. It's the people that made it.
It's the people behind it.
There it is.
Exactly. It's the people coming up with the algorithms. It's the vast army of underpaid people in third world countries that are running the mechanical Turks behind the scenes and training up the.
Thank you for acknowledging them.
And all of that. But yes, let me talk a bit about what I mean by stochastic programming, and I can give you an example. I'll start with a very abstract example, and that is you've got a bag of 1,000 coins. 999 of them are perfectly normal, 50% heads, 50% tail coins. One of them is a double-headed coin. You reach into the bag. You don't look at the coin, you flip it 10 times, it comes up heads 10 times. Now the question is, what is your belief about the question, do I have the double-headed coin or not?
Oh, man.
Because on the one hand, there's only one double-headed coin. You had a 1 in 1,000 chance.
Sure, but there's also a non-zero scenario that I just got lucky 10 times and I still don't know.
Flipping a coin 10 times in a row and having it come up heads happens 1 in every 1,024 times.
Mm.
So since those two ratios, 1 in 1,000 and 1 in 1,024, are almost equal, it's about a 50-50 chance that you have the double-headed coin, which is a lot better knowledge than the 1 in 1,000 chance that you had before you observed those coin flips. Okay, so that's pretty straightforward Bayesian mathematics. The question is, why do we care as professional line of business developers? And the answer is, what we're actually observing is somebody has just joined your social network. There is a 1 in 1,000 chance that they're a real person, and there's a 999 in 1,000 chance that they're a bot. And then they make behaviors that are consistent with being a real person. And so how do you update your prior belief that there's a 1 in 1,000 chance that they're a real person to having a 1 in 2 belief that they're a real person? And in that example, the math is pretty straightforward. But when you start adding in all of the other statistical quantities, it becomes quite a tricky problem to solve these sorts of things in the real world. And so that's what my work was at Facebook, was helping data scientists build language tools that allowed them to represent stochastic quantities in a very clean, understandable way, manipulate those stochastic quantities using the ordinary arithmetic of a programming language, feed into the system a bunch of observations of reality, billions of observations of reality, and then have a quantity come out the other end that is, in this principled way, what is the update to our belief about whatever it is that we have under question? Is this user a real person? Is this router the broken router in the data center, etc.? Whatever the problem was, is this content reviewer doing a good job of classifying content as spam or ham, etc., etc. So all of these kinds of questions where there is some uncertainty, but we have a statistical model that we believe matches reality, and we have some observations of reality. How do we get a good update on our priors? So that was the problem that I was working on with stochastic programming. We're not going to go all the way to that level of detail in the book, but I'm going to go through the basics of how do we represent statistical quantities, how do we compute probabilities, how do we combine those together, how do we apply Bayesian logic to them, and so on.
I gotta ask. Mm-hmm. I remember during the spam wars, mm-hmm. and by the spam wars I mean like the email spam wars.
Yeah,
I largely don't get spam. I get unwanted PR pitches and I get random newsletters. But as a general rule, the spam problem in email, at least for Gmail users, is mm-hmm. pretty much like solved. 1 or 2 spams a week.
Yeah.
But on Instagram, I'm added to a crypto group with random people with random GUIDs for names probably 40 times a week.
Mm-hmm.
And like it's investment groups, all those kind of things. Why is it that, am I seeing the 0.01% that sneaks through and it's just a flood and like we have no idea how big the spam problem is? Or are they getting more sophisticated? Because from a human pattern matching perspective, I'm like, just created the account, picture Bart Simpson as their name, like random username. This is obviously a bot.
Yes.
Why is that not solved when smart people like you were working on it 10 years ago?
Well, okay, so let me
all due respect to all of our friends from Meta that we love
yes,
and appreciate.
of course, and let me say that I don't work for Facebook anymore.
Indeed.
The reason I don't work for Facebook anymore was because the team of people that was doing this research and getting good results, all of us were laid off. The entire division was laid off.
That explains why my inbox is a mess.
So, number one, it's a hard problem.
Okay.
Number two, a lot of the people working on that problem were laid off. Number three, the attackers are very sophisticated, and they're becoming more sophisticated. And number four, I think it's pretty clear from their actions that the people who run social media sites no longer particularly care about the user protection problem.
Okay, so this is less about math. It's more about it's an ongoing battle, and they just kind of stop fighting it actively.
Yes. Now, there certainly is a large amount of math, and that is when I say that 999 new accounts out of 1,000 are bots. That's a little bit high, but it's not far off the mark. There are billions and billions and billions of bot accounts created and deleted every year, and by sheer numbers, some of them are going to overwhelm your efforts to detect them. But yes, it is to my mind a failure of machine learning, and there are plenty of other examples of failures of machine learning on social networking. Like, you would think that a machine learning algorithm would have figured out by now that I have blocked every radio station that shows up on my timeline in Facebook. I immediately block them because they're all content farms, and they're all trying to gain knowledge of the social network so that they can better advertise to the people in that social network. Since I've blocked, probably more than 1,000 of them by now, you'd think that machine learning would have figured that out and stopped showing them to me, but it hasn't, because they're optimizing the machine learning for different outcomes than my enjoyment.
Yeah, that's a great point. It is challenging to also acknowledge that as humans make mistakes, and humans make mistakes every day, all day.
Sure.
And we don't write off humans, but maybe we do. But a computer makes a mistake once, and you're like, it's garbage, right? Like, I saw a Waymo do something crazy. I'm never getting in a Waymo.
Yeah,
there's no way.
I remember when I was a teenager, one of my friends who was also a computer enthusiast said to me, he's like, if we asked a human being to look up your name in the phone book, and then we got irritated because it took them more than 5 seconds, we would be terrible people. But we get irritated about computers taking more than 5 seconds to do stuff all the time. I think it's about what bill of goods were we sold. Right? We were sold that there was going to be a technologically sophisticated future, and yet the technology seems to be getting worse all the time, not better, in terms of its user experience.
Yeah. And I think it's two things. It's, of course, for lack of a better word, capitalism. It's just the reason. The business problem is different, right? Like running a social network that is loving and user-friendly is not compatible with running a business. But it's also that if you make a mistake once, the human pattern matching brain goes, this is garbage. That's 100% of the time it's wrong. because 1% wrong means it's wrong for me and not 99 of my friends. And that's where you get into anecdotes
Yes.
that aren't data. And then, someone will say, oh yeah, I say the word paper towel out loud and I get advertisements from Facebook. They're listening. And I know they're not listening,
No,
but
no, they have way creepier methods than
right,
listening to you to
right. You know what I
determine
mean?
what paper towel brand you use. Yeah.
But you know what I mean? It's like it happens once though, and then you get into confirmation bias.
Yes. Yes. When in fact there's a lot of stuff going on behind the scenes, including it's not listening to the microphone that's on your phone. It is tracking your location, and it's seeing, are you in the same house as another Facebook user or another social media user, and what paper towels do you know that they bought?
Mm.
Yeah, all kinds of stuff like that.
All of this stuff comes back into problems. And one of the things that I like about your book is that your problems are not business problems. You're not solving social media problems. You're solving game of life problems. It's fun. It is a fabulous adventure. You just came out with chapter 7, which is category theory. But I can see the pretty printing one that you just said you're working on. That's only a couple chapters ahead. So I'm going to get that automatically because I own the live book, right?
Right.
So when you finish that, a couple of days later, it's gonna pop into my live book, and then you said at the end, I'm going to get the physical book as well.
Yeah. Yeah. One of the things I wanted to do with this book is have a good balance of uh, code that is useful for solving business problems, and a great number of the algorithms and data structures in this book were ones that I had to learn about to solve a business problem in my business domain of building developer tools. And then some of them are just recreational, but they are recreational in a way that I learned a lot from them. In the chapter on the game of life, there's a famous cellular automaton called the game of life, created by the late mathematician John Horton Conway, where you have a grid of cells that are either living or dead, and the cells evolve over time. And there's an algorithm created by Bill Gosper that computes the future of a given life configuration so fast. It does it in such a clever way, where you can have an enormous amount of data. You can have an enormous life board, much, much larger than would fit into memory somehow. And somehow, the bigger the board is, the faster it computes the future of that board. It's bizarre. And it totally changed the way I think about functional programming. And so I had to include it in the book, not because it's useful for any particular business case. There are business cases that cellular automata are useful for. Cellular automata were invented to do things like fluid flow modeling and things like that. And you find them in modern special effects too, where they're doing like a volumetric analysis of fluids or explosions or things like that. So there is some usefulness, but not for me. For me, the game of life was just an amusement from my childhood. And when I found out that there was this incredible algorithm, I had to tell more people about it.
These algorithms are so crazy because this is a thing that I think it was Douglas Crockford said, that he didn't invent JSON, JavaScript object notation.
Mm-hmm.
He discovered it.
Yes.
Right. And I think that's a really cool way to talk about how something exists out there and it just needs to be found. It's buried in your backyard.
Yes.
Conway's game of life is an amazing thing. You could say John Conway made it, or you could say it existed and he discovered it. And now that algorithm also existed out there and now it just needs to be found.
A lot of the algorithms have that kind of feeling of being discovered rather than constructed, and all respect to the people who did invent
100%.
these algorithms. But yes, it does kind of feel like some of them were just there waiting for somebody to figure them out.
Yeah, makes me think about. I think it was this will be a spoiler for people who haven't seen the movie, but it was the Jodie Foster movie where they find like maybe it was the book. They find the number pi, like they find that contact. They find like a number buried in pi, like deeper than anyone's ever gone before. Or whatever, it's just like sitting there. It'd be just like finding a Post-it note from God, like deeper in a number than you'd ever find before. Like there could be like a ransom note in the game of life, just at a farther out into the grid than we can see, and it like spells out, "You found me." And it's just many, many trillions of games away. So the Fabulous Adventures in Data Structures and Algorithms is up on Manning.com, and you can also check it out at your blog, ericlippert.com, and Fabulous Adventures in Coding. You've actually got an early access discount code up there that I think just expired until it was going till November. I'm going to talk to the folks at Manning and see if we can get folks who listen to this podcast a discount as well. Not so we take money out of your pocket, but so that we can put more copies of the book into people's pocket, because I think you can feel the joy and the fun that you're having in your retirement or your fun employment that you're experiencing. Are you enjoying writing this book?
Oh, I'm having a great time. I mean, all kidding aside about my people who I thought were my friends who convinced the publishers to make me write a book. It is work. It is certainly work to write a book, but I'm having a great time doing it. A lot of the topics are topics that I've explored in my blog before. A bunch of them are new, so longtime readers of my blog will have something new and interesting to check out. And a lot of the times I'm looking at these old blog articles and thinking, it's like, well, past Eric didn't understand this as well as he thought he did, or past Eric did not realize that there was a clearer way to explain this. So it's been a lot of fun for me to revisit a bunch of those topics.
That's so cool. Nothing will make you understand a topic more deeply than being forced to write a book and then have a deadline. The teacher is just one chapter ahead of you. I'm only on chapter 5 right now, but I'm having a blast reading the book, and I appreciate you and your service. We have been chatting with Eric Lippert, and his new book, Fabulous Adventures in Data Structures and Algorithms, is in early access at Manning.com, and you can check out Eric at Eric Lippert, Lippert.com. This has been another episode of Hansel Minutes, and we'll see you again next week.